Hello, everyone, and thank you for taking the time out of your day today to join us for this Johnson Controls webinar, Taking Pneumatics from the Stone Age to the Space Age. We've got a really great presentation that we're super excited to share with you. My name is Jane Walmsley, and I'm a Global Product Marketing Manager responsible for our controls and building automation system portfolios, and I'll be acting as your moderator today. I am very happy to be presenting to you, today from our building's headquarters here in Milwaukee, Wisconsin. So before we get started, I wanted to first introduce today's presenters. Fran Jager is a global product manager in our controls product group and leads our thermostat business. With 20 years of experience in driving development of new products that enhance value throughout the full life cycle, Fran's success is built on delivering differentiated performance as measured by customer expectations. Dan Rumler is a principal engineer at Johnson Controls. He's worked in the sensors and thermostats team for over 7 years and is the lead engineer for the WRZ wireless sensor product line, as well as serving as the resident in-house expert on our WT product line, which you'll hear more about later today. He has extensive field experience with installing and troubleshooting wireless installations for both the WRZ and WT product lines. And also, too, I just wanted to do a few quick housekeeping items before I hand this over to Fran and to Dan. Today's webinar will be recorded, and we'll be making a copy of the recording available shortly after the live event. Additionally, we have reserved some time at the end of today's presentation for Q&A, but we encourage you to submit your questions via the webinar chat or Q&A panel at any point during today's presentation, and we'll do our best to make sure that we get all of your questions answered. If we do, for whatever reason, run out of time to answer any of your questions, we'll make sure that we follow up with the document shortly after today's live event. So once again, thank you for joining us, and with that, I will hand it over to Fran.
Thank you, Jane. So before we get deep into the subject matter, I thought it'd be best to talk a little bit about pneumatic systems, just so that we are all on the same page in terms of why we're talking today. Johnson Controls has been in this business of providing pneumatic equipment for decades, frankly, since before I was born. And given our business, we estimate that there's about 15 million thermostats still in operation today of the pneumatic variety, which is great. But given what they are, most of them operating 24/7, whether anyone's in the room or not, we conservatively estimate that there's about $1 billion of annual wasted energy going through the system, which is not such a great thing. So, historically, our knee-jerk response at Johnson Controls is, hey, I've got a great idea. Let's upgrade your building to direct digital control. Well, as you may know, that comes with a price tag, typically between $1,500 to $2,500 per VAV box, which is great. I mean, you get all sorts of goodness from that, but it may not be what your budget's ready to take on just yet. Most customers see that, get sticker shock, and then just decide to replace their thermostat with what's currently on the wall. And we do see a lot of thermostats get replaced to Johnson Controls. And we estimate that overall in North America, there's about 300,000 pneumatic thermostats put in as replacements on an annual basis. And these are going into all sorts of buildings. Obviously, older buildings. I'm not aware of much new construction going on that's putting in pneumatic systems, but we do see them going into K through 12 schools, universities, airports, government buildings, and a lot of downtown office buildings in some of the more established cities. So, continuing to level set, let's just take a quick look at a pneumatic system, just so that we all understand what we're talking about. And they're quite simple and reliable, which is why they've been in use for decades. It starts with the compressor, which can be a maintenance item in and of itself, but in large part, they work well and last quite a while, and they put out air at typically 70 to 90 PSI. Then they go through some equipment that conditions the air, dryers and filters, just to keep us from pumping contamination throughout our building and through our control equipment. And then once we get to the pressure relief or reducing valve, we're stepping down to 15 to 20 PSI before we get to the controlling device. And in today's discussion, our controlling device is going to be a thermostat. And the thermostat is going to regulate that mainline pressure to a branch line pressure. And it's going to use a bimetallic strip that's going to bend depending on the temperature and control what that branch line pressure is going to be. And, why don't I pause there and acknowledge that it's that mechanical aspect of the device that gets out of calibration over time, which results in your hot and cold calls on an ongoing basis from various tenants in the building. In any case, whatever the branch line pressure is simply going to go to a damper or valve actuator that's going to control the heating or cooling of a particular zone. So, as I've sort of touched on going through that, the pneumatic thermostats are going to require regular calibration in order to avoid, ongoing discrepancies between set point and actually experienced temperature. You're not typically going to have any centralized operation with these systems. If you want to know what's going on in the zone, you're going to have to go to the zone. You're flying blind. Years ago, we used to tout how great these devices looked and how pleasing they were. I guess in today's day and age, they look kind of dated, which may not be a big deal. Even in the room that I'm in today, we've got one of these on the wall, and it's fine. But if you're dealing, say, with a legal office, or worse yet, maybe a marketing firm as one of your tenants, they're probably not going to be well received in terms of having a pneumatic thermostat. They're going to be looking for a more modern interface on the wall to be able to control what's going on. And then, of course, as I mentioned, most pneumatic systems are operating 24/7, whether someone's in the room or not, or whether it's the nighttime or the daytime. Now, as I mentioned, the best solution, removing all of the barriers of finance, is going to a direct digital control system. However, to do that, you're going to have to disrupt whatever is in the space. If that's tenants or your own people, there's going to be some amount of disruption because you're not only going to be moving stuff on the wall, but there's going to be the control devices that are, potentially in the walls and in the ceiling. And some of those circumstances could be, situations where there's a lot of interior decorating there, or, the worst case scenario is something like a museum where there's a display built around where this equipment might be that would have to be disrupted. And the other possibility, given that pneumatic systems tend to be in older established buildings, is there could be asbestos there and there could be lead paint on the walls. So going to DDC could be opening an additional can of worms that it may not be the right time to address. And then from a sustainability standpoint, to the extent that you're doing this, you got to recognize that you're going to be ripping stuff out of your building that's perfectly fine and working. So the question comes, is there a way that we can get to a better solution without necessarily undergoing these inconveniences and throwing away perfectly good equipment and spending more money than we'd like to? Well, there is, and the solution will save us the money, it'll increase our staff productivity, and in fact, it'll get us a payback in less than 3 years, and I'll show you that in a subsequent slide. It's our WT4000 series pneumatic thermostat and associated networking equipment, and using this, we'll be able to achieve what I just described. You won't have to replace the valves that are in the walls and ceiling, won't have to string any wires because they're wireless devices using the established pneumatic tubing. And in fact, they're plug-and-play devices. You're going to be able to get this on the wall and get it operating in less than 30 minutes. I've done it myself. I know very little about this, and just as a control experiment, I was even able to do it in less than 30 minutes. It's non-invasive, so your tenants won't be particularly disrupted. Yeah, a maintenance guy will have to walk through for that, less than 30-minute time period, but there won't be a lot of noise, and there certainly won't be opening up any walls. Other key point is, unlike the DDC conversion, you can do this on a fairly limited basis. I've had customers who've just wanted to try this out, and they've hung one on a wall in their office, where they just wanted to find out how it operated and if it operated to their level of acceptability. You can also do it zone by zone. In other situations, I've had tall office buildings where folks have tried to do it floor by floor, more so to control their budget than actually to try it out, because there's a full commitment to the project, but not a full commitment to writing me a check all at once. And in doing this, you can get your remote set point control and your continuous zone monitoring and much more that we'll discuss.
And hi, everybody. This is Dan Rumler, Principal Engineer in our Thermostats and Sensors group, like was said before. Thanks to Fran for covering more of the business aspect on here, but I wanted to get into some more of the physical and technical details of this so you kind of understand this product a little bit better. So on your screen right now, we have the back-looking face of the WT4000. Now, when you would be replacing a regular pneumatic thermostat with a bimetallic strip or other mechanical interfaces, essentially all you have to do to install this is to pull the old one off the wall, and you connect the same exact branch and main line tubings to those plastic barbs that you see with that first arrow going in there. And all you really need to do for mounting is take the back plate and put a few screws in the wall. So it's really easy installation. You don't need to run a whole bunch of different connections and things of that sort. So it's a couple screws and connecting the exact same tubes that are already existing in your wall. A little bit more on how this actually works. What we have in the past was that bimetallic strip that would kind of change physical shape to release or allow more air to go to pneumatic load. What we did now is take a more digital control on there. So that valve right in the middle of your screen there, that's a piezo valve. It's a medical grade valve. And what we do is we take the mainline pressure and we feed it to the branch line, and we can either increase the pressure by bringing more of the mainline pressure in there, or we can bleed off the pressure on the branch line. So it's a very precise control. We have a PID loop in there that controls all that, and it does not require any calibration because it's all completely digital within there. The next item on here is the battery holders. They're pretty self-explanatory. We have 4 batteries on there, and they're clearly marked, and it's very easy installation. You don't need to take anything apart, unscrew anything to get at the batteries. If you ever have to change them, you simply clip it off the wall, and you can replace the batteries in a matter of seconds. Down in the bottom right, we also have a termination for a motion sensor input. Now, this would be an external sensor that we also provide as an accessory if you need it. This is the typical application of this is for added energy efficiency. So if you want to actually detect if someone's in a room, if there's movement or not, you can actually change the state instead of waiting for a timeout period, things of that sort. It can bring the room to a more loose control instead of tight control, thus limiting your energy usage. The last one on here is the optional 12-volt DC VDC supply terminal. This is in the case that you don't want to use batteries. It's totally optional, but if you happen to be able to run power to this and you don't want to have to worry about changing batteries out ever, we do also offer the option for wiring these as well. Moving on to the next slide here, talking a little bit more about the battery power and the expected battery life of this product. We ship with 4 3.6 volt AA lithium thionyl batteries. We offer these as an accessory as well. So if you ever have to replace these, they are readily available through Johnson Controls. You don't need to go and try to find these out on the market anywhere. We readily supply them to you. A typical battery life of this is about 4 years due to it's a little more energy hungry application due to running that piezo valve, but we can get about 4 years battery life in a typical system. This will actually improve if your system is very well maintained. The more times it has to actuate and change the pressure in the line, the lower the battery life is going to be. So if it's well maintained, you can see well upwards of that. The batteries themselves have a shelf life of 15 years. So you can get quite a bit above 4 years if you have a very well installed system. We also have an LCD on this, and it offers quite a wealth of information on here. So kind of starting in the top left, we'll kind of walk around this picture here to show you what you actually will be able to see on this product. So first, there's the operating mode. This will tell you the current state. It will either be in shoulder mode, which is a night setback mode. There's an unoccupied mode, which is a little bit looser of a range. And then there's the occupied mode where you're doing full control for an occupied space. In the top right, we have the wireless connection status. This will show you if you're connected wirelessly to your system. We also have an indicator if you're using the standalone mode on there as well. It's a little person that shows up on there. The next one is the routes back to the gateway. So this is the number of wireless routes back to the WT back IP supervisor in the wireless system. This shows you how many routes you have back. The more, the better. I'll get into that in a little later slide talking about the actual wireless network. We also have the battery voltage level, so you can monitor the battery voltage. It just won't creep up on you and suddenly die on you. We have the hot or cool output, so you can tell the state at a glance of the stat. Also, we have a fan output state, where you can see the state of that as well. And then we have these 4 numbers on the bottom, which show you the wireless signal strength indication, and then also the measured and actual, or the requested and the actual branch line pressures. So you can actually see the pressures that this is putting out. And one other handy troubleshooting item is the air control on air code display. It relates to certain typical failure modes and can help you better diagnose your system. And then lastly, the user interface and the keypad we have on here. Of course, we have the LCD, and we have the standard up and down buttons for changing through menus and also changing the temperature set point. The shoulder mode button puts it into an unoccupied state. The override button puts it into the occupied state. And if you happen to be in an unlit room, you have a light button that will illuminate the screen there as well.
Okay, thanks, Dan. I'll just pause for a moment. I'd like to make an observation about the overall aesthetic design of the device itself. We made it the way it is for a couple of reasons. You'll see that the LCD display is somewhat subdued off in the corner, and that's in part because we want to conserve energy in this thing. Dan mentioned that we've got, conservatively speaking, a 4-year battery life. Well, that was the design minimum that we wanted in there. We did not want to be replacing batteries on an ongoing basis, essentially substituting calibration with battery replacement. So we went to an energy conserving display, a small display, so that we'd be able to maximize the amount of life we get out of the battery. We also wanted to minimize the overall user interface as opposed to putting a flashy thing on the wall. We didn't want to create an attractive nuisance out of this device. We wanted something that would blend in, that wouldn't cause wandering hands to start probing at it and changing set points when essentially defeating our energy saving intention on this. But it is a very nice electronic device, full featured, and I'll walk through a number of the other things that come along with it, given that. So Dan told us some things about the air valves in this, but since we have these valves available in a digital device, we're also able to monitor the various pressures in there and can detect if there are leaks or anything else going wrong with the system, which is a great thing because that preemptively gets ahead of some other problems that could happen down the road and prevent some additional wear and tear on the compressors and other equipment on the system. And actually, we just recently had a situation where some folks were installing a bunch of these, and they gave us a call complaining about the error codes they were getting. And we explained that, well, the error codes that you're getting is because we've just found that you've got a problem in your system that you may want to correct before you let the installers out of the building. They had some very leaky hoses going on, so we were able to correct that as part of the installation process and move on with a very sound installation. Dan also mentioned the batteries had the 4-year life. Well, we don't want to roll the dice and expect a 4-year life or hope for a 4-year life. We actually monitor the batteries on an ongoing basis, and that becomes a point for your BAS system, or it's apparent from the display on the device, so that you're able to change out the batteries before you find yourself coming in the morning either way too hot or way too cold. You're able to see it coming and take care of it proactively. With our pneumatic thermostats, one thing we do experience is that we get a call for replacement and we'll ship out a direct acting thermostat only to get a call a few days later where the customer actually needed a reverse acting thermostat. So this particular device, one SKU, will do the same. We'll do either or. It's in the software. It's a software selectable switch. If you guess wrong, you just have to switch it the other way to get it right. We as the manufacturer don't have to stock multiple SKUs, and you as the customer don't have to worry about returning the one you accidentally bought and buy the other one. And of course, the air valve, we keep emphasizing, it does not require the mechanical calibration. It calibrates itself, it's maintenance free, and it should eliminate the hot and cold calls that you experience as a maintenance staff. The binary input for the dry contact. Now, it's important because although this thing allows either your BAS or your programmable schedule to get some energy savings for you, if you're in something like a school that a classroom may be occupied maybe half of the time, a motion sensor will get you up to an additional 30% energy savings. So the availability of this contact is not a minor nicety. I would encourage in those situations that you include the occupancy sensor with your purchase. And then I mentioned in terms of programmability, these things, the same SKU will operate either in standalone or in a network BAS situation. Obviously, if you have this thing plugged into Metasys, you get access to all the points and make it do whatever you want it to do. But if you want to just try these out or do a small zone test, these things are operated standalone devices, just like your current pneumatic thermostat. You just plug it in the wall, less than 30 minutes, as I described before. And within the standalone, you can get into the programming mode. And it's got a 5-day, 2-day, essentially the work week and the weekend programming functions that you can set it up appropriately for whatever your typical operating schedule is and get those energy savings without even having to network this device.
All right, thank you, Fran. We're going to talk a little bit more about the installation now and what the overall system topology looks like when using the wireless function. As Fran said, you can also use it as a standalone device and you don't need to buy the rest of the system and you still get quite a bit of energy savings. But to be optimal, putting in the full wireless system is your best option. So taking a look at the diagram on your screen, we see the WT4000 pneumatic thermostat on there, which we consider an end device on there. Then in between, we have the WT router, which routes the signals as the name implies. You can think of it as a signal repeater or a range extender. And then finally, we have the WT back IP, which is kind of the brains of the system, which kind of takes all the data and feeds that over BACnet IP back to your BAS controller, be it one of our Johnson Controls NAEs or a Tritium controller, anything that accepts the standard BACnet IP protocol, it will work with. So going into this a little bit, if you're not familiar with wireless mesh systems, Wi-Fi, for instance, is a point-to-point wireless protocol. So it just talks from your computer directly to the access point back and forth. However, with a mesh system, as you can kind of see here, we have a web topology. So there's actually redundant paths that you can take. So in the instance that if you're doing new construction in a constantly changing building and someone puts up an elevator shaft or a very large brick wall in between there and disrupts the system, it will actually find its way around there and you don't need to reinstall equipment or relocate things. It's also very insusceptible to RF noise. So if you have a lot of Wi-Fi going on, if it's on some strange channels, it has the ability to work through that with a patented algorithm to avoid that noise. Now we have a few little animations on here to kind of help visualize that a little bit. So this first one will show you that from the stat, it can go a couple different ways to get back to the gateway. And then likewise, going from the gateway back to the stat, it can write down values and send confirmation signals and things of that sort. Now, as I mentioned, it can go around obstacles. So in the case that it sees an obstacle, it can go around that as well and still get back there without dropping the signal and having to retry, using more battery life and having latency in the system. So this is a very bulletproof system, and you should not experience any wireless issues, communication issues due to this topology here.
So just to summarize some of these goodness, and for this slide, I've classified it, based on the audience as to who you are. If you're listening and you either own or you're the facility director of the building, I mean, the big things that you're going to take away by implementing this sort of solution is that you're going to get your energy savings. That's going to be the big dollar amount that's going to come back to you. But almost as big is going to be the labor savings. And if you're finding that your maintenance staff is running around the building on an ongoing basis, taking hot and cold calls, or people banging up their thermostat because it's not doing what they want it to do, this should get you past all that and get your maintenance people doing what you want them to do, being more productive. It's an alternative to full DDC. It's going to get you a lot of the good features to that for a lot less cost. There are installations, and actually most installations nowadays, they're concerned about security. And this password protected is an understatement. Our security is essentially bulletproof on this too. As Dan mentioned, this is a proprietary mesh network. It's not going to be susceptible to a typical attack that might come through Wi-Fi. So, and we can discuss that on an individual basis if someone is particularly interested in that subject. This is a solution that you can grow with you. Again, you don't have to do it all at once. You can do a zone, you can do one thermostat, you can do a floor, or you can do your whole building and then subsequently expand to another building on your campus. So lots of options for how you can approach this depending on your budget. Key aspect to this is tenant retention though, that versus a pneumatic thermostat that may be running hot or running cold depending on your calibration. This is going to keep those tenants comfortable. And the feedback that I've gotten is that you're much more likely to be able to return those people, to rewrite those leases, and keep someone in that space. Now, if you're a contractor or a maintenance person, the good stuff that's in here for you is that you're not going to get those hot and cold calls anymore. That lets you focus on what you want to focus on. These things are direct replacements for the pneumatic thermostat. So it's not like I'm going to have to bring you in for a whole bunch of training to figure out how to deal with this. It's, take one thing off the wall, plug this device back into the two hoses that were connected to the pneumatic thermostat, and hang it back on the wall. A little bit of setup in terms of the menus, but it's very straightforward. And we can walk you through that, but we also have the printed literature and online literature to help you through that. There's no wires involved. So if you're concerned about wiring, as we mentioned, it's a battery-powered device. Again, very plug and play. Reuses the same pneumatic tubing, and I emphasize the external occupancy sensor, that if you want to get that extra up to 30% energy savings, that's a nice thing to do as well. That would be an additional thing to install, but that's a no-brainer. If you're in a situation where you've got a room that's it's occupied, not on a set schedule during the occupied period. So let's talk a little bit about the economics. Now, for this slide, I'm throwing on a figure of $600. The device doesn't cost $600, but just to make sure that I don't get sideways with any of my channel partners or what they want to charge for labor, I'm going to say that the cost difference is $600 versus a pneumatic thermostat. Even if I do that, and I run a Department of Energy calculator, now this isn't the Johnson Controls calculator, it's one that we get from the Department of Energy based exclusively on setback thermostats. You can see the energy savings that we get with the weather data from Chicago, Miami, and Nashville. Even at $600, I'm 2 years of payback, typically better than that. And if you use the actual figures of what you wind up paying for this device, and I'll leave that to you and your channel partners, you're going to find that you're going to get this thing paid back at substantially faster rates than that. So again, to summarize, great solution. Short of going to DDC, you get out of the calibration business, you get your occupancy scheduling, whether standalone or through BAS, you get remote monitoring if you do BAS, and of course, pneumatic building automation, which prior to a device like this was just a dream. So Jane, I'll turn it back over to you, and we can address any questions that might have come over the line.
Absolutely. Okay, great. Thank you very much, both to you, Fran, and to you, Dan. I saw a couple of questions coming in while you were both delivering your presentation, but we do have plenty of time left, so if you still have not had a chance to submit your questions through the question or the chat panel, we certainly encourage you to do so for the next couple of minutes. But in the meantime, we'll dive right in. So I will throw this out to either of you. Will the stat communicate without the WT router repeater that Dan, you showed in your network diagram earlier?
Yes, if it's a smaller network and it's close enough, it can talk directly to the WT back IP. It does not require the routers, but on a typical installation, if you have quite a bit of space to cover and a larger number of stats, we do recommend them. The typical installation suggestion we have is for every 10 stats, you have one router. So just using that kind of rule of thumb when installing.
Okay, great, thank you.
Another key aspect is, and we publish a best practices document to address some of these, but we highly recommend having multiple paths back to the gateway. And it's even helpful if the thermostat can reach the gateway by its distance all alone. If there's any interference or anything going on that could potentially be disruptive, having a second path for that thing to eventually get to the gateway makes it a much more robust system.
Okay, great, thank you.
And the obvious one, and this came up a little bit when Dan was presenting it, is in an office building, you've often got elevators and bathrooms in the middle, which, it's an obvious obstacle to a radio signal. And to have multiple paths going either way around that particular obstacle is an obvious solution to that.
Got it. Thank you very much. Does the WT4000 itself act as a repeater?
The WT4000 does not act as a repeater. The reason for that is battery life mainly. In order to be a repeater, you have to be constantly listening for transmissions to relay. So it's really only going to wake up every 5 minutes to conserve battery life. It continually monitors the pneumatic pressure on the lines every intervals of 30 seconds, but it will only transmit once every 5 minutes. But if you do have a more high-level priority command, like changing the set point and things of that sort, it will go faster than 5 minutes. It will do that on demand instead of on intervals.
Okay, great, thank you. So if someone's using an occupancy sensor on that network, is the occupancy sensor powered from the stat itself, or is there an external source when using batteries?
You will require an external power source for that motion sensor, depending on what that is, but you do not need to pull power from the WT4000 for that. All the WT4000 does is accept a dry contact, basically an open-closed signal to dictate whether it's occupied or unoccupied.
Yeah, and that's a fair point. Although I strongly encourage folks to take that opportunity for energy savings, it does. I mentioned it's a plug-and-play device. It isn't quite plug-and-play when you go to a remote or occupancy sensor.
Okay. Let's talk about mounting for a second. Does the WT4000 get mounted in the PStat box?
In the PStat box, I'm not familiar with.
I think it's just mounted as.
Yeah.
Maybe you can just explain how it's mounted.
Yeah, there is a backplate. I don't believe we have a picture of what that looks like, but it is it's not too large, and it does mount to. It will actually mount to our standard Johnson Controls backplate on there. The T4000 backplate, it can mate with that.
Okay, great, thank you.
Oh, and you touched on something that I think we failed to mention, that it's easy to replace a Johnson Controls pneumatic thermostat. It's just as easy to replace anyone else's pneumatic thermostat. Yes. So this isn't exclusively hey, I've got a Johnson Controls T4000 to replace.
Okay.
So if you've got something from the other guys, it's just as easy to replace their stuff.
Okay, great. So, and maybe one of you could toggle back to a picture of the actual stat itself. So someone asked about the fan icon in the LCD screen. Does that control a fan?
Right now, that is not active in our current design, but that is something that we are working on. That would be active on the relay models.
There are there's actually 4 models of this device, Fahrenheit and Celsius.
Okay.
And then the other split is whether it's an occupancy sensor or the fan relay. And it's this fan relay that Dan was describing.
Okay. Kind of going back to the power supply discussion, if someone is using a regular power supply instead of batteries, could the stats operate as repeaters then?
We don't currently have that
Okay.
operability built into the firmware at this point.
Okay. All right. And if there isn't an existing BAS in the building, is there software available for remote monitoring?
There is. We don't currently offer it as a product, but there are solutions where you can have the stats talk back to a central device that talks to a computer.
Okay.
So if that's desirable for someone to go that direction, and interestingly, I haven't been asked that question before because, I guess we've been dealing mostly with folks who have Johnson Controls BAS systems. But if that's desirable, we can work with you to find that solution.
Okay, great. Could someone wire the occupancy contact as a simple mode control without a front end using relays?
As long as a dry contact signal is given to the WT4000, it will interpret I believe it's open is unoccupied and closed as occupied. So whatever that implementation happens to be, we can feed it in that way.
Okay, great. So since if you need routers or repeaters to extend the WT4000 thermostat range, how many thermostats can a router serve?
I believe I answered that before. It's about a 10 per.
Okay.
We do have very good range with these. These are 100 milliwatt radios. I believe our statement is that they go about, I just want to double check to make sure that I'm stating this correctly. It's about 200 feet indoors. It's a very powerful radio. It's North American only, so it isn't sold in Europe, where we're limited to 10 milliwatts. So if you do have a smaller building and you do want to talk directly to the BACnet IP and not want to install routers, you have the capability of doing that, though we prefer you put routers in for the redundant signal paths.
Okay, got it, thanks. So someone heard that the scheduling is 5 and 2 days for a setback. Is there going to be a 7-day scheduling thermostat, and can that be done through the BAS?
Yes, the BAS is the overall governing system on there. So you just basically implement your schedule as needed right into the BACnet points on here to implement that.
Okay, great.
Yeah, we weren't planning on changing the standalone mode from 5.2.
Okay.
And really, if you wanted a 7-day schedule, you just make the weekend exact settings the exact same as the weekday settings.
Okay, great, thanks. And can the WT4000 connect to the new Verisys control system? That's our new control system for the mid-market light commercial sector.
I'm not sure, 100% sure on what input capabilities Verisys has, but as long as it supports BACnet IP, it will be able to bring all those BACnet objects in there.
And we can certainly circle back with our Verisys.
Yep, we can double check that.
Answer there. Okay. I think that was the last question that we received. So I think with that, we'll conclude today's presentation. We'll leave the webinar panel open for just a little while longer if someone wants to submit any more questions that they maybe haven't thought of just now. And once again, we'd like to sincerely thank you for our time. Thank you to Fran and Dan for presenting. As I mentioned earlier, we'll be making sure that a copy of today's presentation and the recording is made available shortly after the live event, as well as any questions that we didn't answer or that may come through after we end the formal session. So again, thank you very much for your time. Fran and Dan, thank you again, and everyone enjoy the rest of your day.